Solve using Jacobi's method. The system of linear equations 5x minus y plus z equals 10, 2x plus 4y equals 12, x plus y plus 5z equals minus 1. Given the initial guesses x0, y0, z0 equals 230, find x2, y2, z2. In this question, we have been specified to find only till second approximation. That is, we will find out x2, y2 and z2 using iterative formulas which is obtained by solving these three equations. First, we will check for diagonal dominance property, which ensures that this method will converge to approximate solution. In the given set of linear equations, we have 5, 4 and 5 are the diagonally located coefficients, and we have in first equation absolute value of 5 is greater than absolute value of minus 1 plus absolute value of 1. In second equation, we have absolute value of 4 is greater than absolute value of 2 plus absolute value of 0, where 0 is the coefficient of variable z in second equation. In the third equation also, it is true that absolute value of 5 is greater than absolute value of 1 plus absolute value of 1. Thus, in all the three equations, it is remaining true that coefficients of diagonal elements whose absolute value when considered is greater than sum of absolute values of remaining coefficients. Thus, diagonal dominance property holds true here. We have from this equation x equals 10 plus y minus z divided by 5. From the second equation, we have y equals 12 minus 2x divided by 4. From the third equation, we have z equals minus 1 minus x minus y divided by 5. We have first approximation which can be evaluated using the initial approximations x0, y0 and z0. We have x1 equals 10 plus y0 minus z0 divided by 5, where y0 equals 3 and z0 equals 0. Thus x1 equals 2.64. y1 equals 12 minus 2x0 divided by 4, where x0 equals 2. Thus we have y1 equals 2. z1 equals minus 1 minus x0 minus y0 divided by 5, where x0 equals 2 and y0 equals 3. Thus we have z1 equals minus 1.2. In order to find out second approximations x2, y2, z2, we will depend on x1, y1 and z1. We have x2 equals 10 plus y1 minus z1 divided by 5, where y1 equals 2 and z1 equals minus 1.2. Thus x2 equals 2.64. y2 equals 12 minus 2x1 divided by 4, where x1 equals 2.64. Thus we have y2 equals 1.68. z2 equals minus 1 minus x1 minus y1 divided by 5, where x1 equals 2.64 and y1 equals 2. Thus we have z2 equals minus 1.128. Notice that in consecutive iterations, values of x, y and z are coming closer and closer.